Agentic AI dashboards should do more than report activity. They should connect what systems spend, how they perform, and whether they create value, so teams can govern confidently and make smarter optimization decisions. So far, we've explored what drives agentic AI costs, how to measure, tag, and allocate those costs, and how quality metrics connect to business value. Now we shift to communication, turning observability and allocation data into dashboards that help teams decide, optimize, and govern. Dashboards in Agentic FinOps are not decoration. They are the operating layer where signals become decisions. Spend, token volume, latency, errors, evaluation scores, allocation tags, and business outcomes all need to come together in one trusted view. That keeps teams from optimizing cost while ignoring quality, or improving reliability without understanding value. Strong dashboards also support different operating rhythms: immediate alerts for operators, weekly optimization for engineering and FinOps, and monthly reviews for leaders. The goal is shared accountability, with trends, thresholds, and actions visible to everyone who influences AI cost and performance. A strong agent dashboard starts with the decision it supports. Before choosing metrics, ask, what action should this trigger, and who owns that action? An operations lead needs latency, failures, and workflow bottlenecks. Finance needs spend, unit cost, and forecast variance. Executives need trend, risk, and business value. Keep dimensions consistent so people can compare by team, product, agent, workflow, environment, model, or customer segment. And most important, never show cost alone. Pair it with quality, reliability, and value, or you may optimize for cheaper agents that quietly create worse outcomes. AI agent reporting works best as a chain from resources to results. Begin with spend, what you pay for models, tools, storage, and infrastructure. Then track usage, requests, tokens, context, tool calls, retrievals, and users. Next, measure quality and reliability. Whether the agent succeeded, how often it hallucinated, how fast it responded, and what failed. Finally, connect those signals to value: cost per outcome, revenue influence, deflection, productivity, ROI, and adoption. This taxonomy keeps teams from optimizing one metric in isolation and helps leaders see the full operating picture. For engineers, this is the agent's cockpit. It shows whether the system is healthy while real users are depending on it. Teams monitor token usage to catch cost spikes, latency to find slow steps, and failures such as retries, timeouts, or broken tool calls. They also watch task success and evaluation trends, so a model change does not quietly reduce quality. The goal is fast diagnosis before small issues become incidents. Token reporting turns model cost into something you can diagnose. Start by separating prompt, completion, cached, and retrieval context tokens, because each grows for different reasons. Then compare usage across workflows, models, prompt versions, user segments, and task types. The goal is not just to see total spend. Watch average tokens per request, and more importantly, tokens per successful outcome. Percentiles add useful context. P50 shows the normal case, P95 shows costly complexity, and max sessions expose edge cases where agents loop, retrieve too much, or carry oversized context. Reliability monitoring has to follow the whole execution path, not just the final answer. Break latency into model inference, retrieval, tool execution, orchestration, and external APIs, so teams can see which component is slowing the run. Track retries as a signal, not a footnote: how often they happen, what they cost, and whether they actually recover the task. Group tool failures by tool, endpoint, dependency, and agent step. The key is correlation. Repeated retries may raise cost while lowering answer quality. Cost optimization only works when quality is measured with the same discipline as spend. For every model, prompt version, workflow, dataset, and release, keep an evaluation score that can be compared over time. Then connect offline test results to production signals, such as task success, hallucinations, user corrections, escalations, and safety events. This helps teams catch regressions after a model swap, retrieval change, or tool update. The goal is not to pick the cheapest route. It is to report the trade-off clearly: cost, latency, and quality together, so teams know what they are gaining and what they may be risking. FinOps dashboards turn raw AI usage into decisions that finance and engineering can act on. Start by comparing actual spend with budget at the level teams manage: product, agent, model provider, and environment. Then look forward with forecasts, checking whether projected month-end or quarter-end spend is drifting from plan. Allocation tags connect each dollar to an owner or business unit. Just as important, the dashboard exposes what is not allocated: shared platform cost, missing tags, and compliance gaps. That is where cost visibility becomes cost control. Total AI spend is useful, but it does not show whether the agent is creating value. Start by defining a successful outcome: a resolved ticket, completed workflow, generated report, approved recommendation, or automation that ran correctly. Then collect the full cost of the agent, allocate that cost to those outcomes, and divide. For example, $12,000 in monthly agent cost across 8,000 resolved cases equals $1.50 per case. Segment that number by complexity, customer tier, channel, model, and workflow path to see where optimization matters most. For executives, an AI agent dashboard should answer 3 questions. Are people using it? Is it creating value? And are the trade-offs acceptable? ROI should connect to real business outcomes, such as revenue influence, labor savings, faster cycles, deflection, or productivity gains. Adoption should show where momentum is building by team, region, workflow, or user group. Leadership also needs balance. Include cost per outcome, quality signals, and risk indicators so the story is credible. The strongest dashboards end with a concise narrative: what changed, why it matters, and what decision or action is needed next. Anomaly detection is the early warning system for AI operations. It looks for patterns that break from normal behavior, not just absolute limits. A sudden cost spike might point to a traffic surge, retry storm, or workflow loop. Gradual token growth can reveal bloated retrieval, expanded prompts, or context that keeps accumulating. Quality anomalies may appear as falling evaluation scores, more failures, or increased human escalations. Usage shifts matter too, especially when traffic silently falls back to premium models or unauthorized providers. The goal is to catch these signals while they are still small. Observability only works when alerts lead to action. Start by defining thresholds for the signals that matter: cost spikes, quality drops, runaway loops, token growth, error rates, and unexpected model usage. Then route each alert to the team that can actually respond. Engineering handles incidents, FinOps handles budget variance, and product handles adoption or value concerns. Severity levels keep every notification from becoming a fire drill. Finally, govern the dashboards themselves. Keep metric definitions clear, assign owners, check data freshness, and review reports regularly. That discipline keeps monitoring trusted, useful, and operationally sustainable. Dashboards turn AI telemetry into action. The strongest reporting connects spend with usage, quality, reliability, and business value, so engineering, FinOps, and leadership can make decisions from the same evidence. Alerts close the loop by catching spikes, degradation, and unusual model behavior early. Next, we use these signals to optimize model choice, routing, prompts, context, and retrieval.